Hello everyone, this is Mr. Molo for lesson 5-1, solving systems of linear equations by graphing. So we're going to do this a couple different days, a couple different ways, and it's really your choice which way you're going to do it. So we're going to do it one day by graphing, one day by substitution, one day by elimination. Elimination's my favorite, but you kind of get the choice then at the end once you figure out which one you like best, and how the problem's kind of set up kind of depicts on which system you should choose. So we're going to do this 3 different days, 3 different ways, so you kind of get a mix of all 3. So this one we're going to do by graphing. And this is another one of those lessons where mom and dad will say like, oh, I never use this in life, but really they do, except they don't really call it a system. And this will kind of be like the first real thing of algebra, I feel like, where you're solving for like x and y to try to figure out something. So it kind of feels more like algebra to me. So for this first exploration here, your family opens up a bed and breakfast. Okay, they spend $600 preparing a room to rent. The cost to your family for food and utilities is $15 per night, and they charge $75 per night to rent the bedroom. Okay, so if they're doing like an Airbnb or something like that where they're renting out a room, they want to make a little extra money, this would be a good equation to figure out how long it's going to take them to start making money, or how much money they're going to lose if they don't rent it. So our first equation is we're going to write an equation to represent the cost. Okay, so every time someone stays there, it's $15 per night. The lights are going to be on in the room. They're going to take a shower. You're going to feed them some food. So $15 for every one person that stays there. And then they had to buy some new furniture for that room. Maybe it was an empty room in your house, so they had to buy a bed and a nightstand and a TV or whatever. So they spent $600 doing that. Okay, so that's how much the room is going to cost your parents. The profit is here. So they're going to make $75 each night someone rents that room. So now we have to figure out, well, how long is it going to take them to start making money? Okay, so our cost, even if someone stays there 0 nights, well, it still costs them $600 to get the room ready. So even at 0 nights, they're down $600. And then someone stays there 1 night, well, now they paid $600 to get the room ready, plus that $15 we talked about for food and water and electricity and stuff like that. So now we're just going to keep adding those $15 every night somebody stays there. So it's not going up like $600 every time, but it's going up a little bit each amount. And it'll kind of make a difference then when we start seeing a profit then of when we get there. So after 7 nights, someone's been there for a week. It's $705, then $720, then $735, then $750. We'll stop right here. So after 11 nights of someone being there, it cost your parents $765. The $600 for getting the room started, and then $15 a night for like the stuff we talked about before. Okay, let's pretend no one has rented the room, so your parents have made no money. Okay, after 1 night someone's there, they paid them $75. Okay, so now your parents made $75, but it still cost them $615. So they're really not making money yet. And then after 2 nights, they're at $150. All right, so we're getting closer. And then $225, and then $300. Still about $330 off there. Or $360 off there. Sorry. Now we're at $375. Now we're $300 off even. Okay, now we see the numbers are getting closer. Now less than $200 off. Now about $120 off. And we see right here, this is the magic number. After 10 nights, we end up figuring out that it is exactly the same money. It cost your parents $750, but they made $750. So there's $0 profit, $0 loss. And then this right here, if they get someone to stay there for 11 nights, that means they made money. They made $825, and it cost them $765. So really, they made money on that then. So they made $60. So everything after that, now they're going to start making more and more money every time, because we kept going with 12 and 13, 14, 15 days, all that stuff. You can figure that out. Same thing. Some of you might have cabins up north and your parents rent it out because you're not there every weekend, and they have to figure out, well, how much are they really making on that cabin if they have to come in and get a cleaning lady to clean it up, or somebody breaks a dish or something and they have to replace the dish. Okay, so we can use systems to figure out our answers or stuff like that. Okay, so on this homework, kind of like most homework, there's kind of a couple different questions. So this is like one kind of question right here, these 1 through 6. So you're just telling me, yes or no, is 3, 1 an answer to these two problems? So remember, x is 3, y is 1, x is always the first number, y is always the second number, and you're going to plug these in and see if it's true. So if I plug in this first number, x is 3 and y is 1, I get 3 plus 1 equals 4. Yep, Mr. Molo, that is true. 3 plus 1 does equal 4. Now if I plug in my x and y for the second problem, I get 2 times 3 minus y, so minus 1, and the book thinks that equals 3. Well, 2 times 3 is 6. 6 minus 1 equals 3. Well, is that true? 6 minus 1? Nope, 6 minus 1 is 5. That does not equal 3. So 5 does not equal 3. So I'm going to say no, this is not true. 3 and 1 are not my answer for that problem. Okay, let's look at number 2 here. So I have a 1 for my x and a 3 for my y. And I'm going to do the same thing. 1 minus 3. And the book thinks that equals -2, and they're right. 1 minus 3 does equal -2. Now we're going to plug it in for the bottom one. It says 2 times x, and x is 1, plus y, y is 3, and the book thinks that equals 5. Well, 2 times 1 is 2, so 2 plus 3 equals 5. 2 plus 3 does equal 5. The book is right on both of them. So since the book is right on both of them, number 2 is going to be a yes problem. Since 1 and 3 make both equations true, it is going to be a yes problem. Okay, if we get a no right away, those are kind of nice because then we could just stop right there because it needs to be yes for both of them. It needs to make sure that it does equal -2 on the first one, 5 on the second one, so it needs to be a yes for both. Okay, let's look at number 3. Now we got y, 0 equals 2 minus 2. So 2 minus 2 is 0, so that works. That is a yes for the top one. And here I have a 0 for my y, so 0 equals -3 times 2 plus 6. So -3 times 2 is -6. -6 plus 6 is 0, so that is also true. That is a yes as well. So number 3, we got 2 yeses. So yes, yes, makes it a yes overall. Okay, let's look at another one that's going to be a no here, like number 5. I'll give you a hint, it's going to be a no. So I got 3 times x, so 3 times -2 minus 2y, and y is 3, and the book says that that should equal -12. Well, I got 3 times -2 is -6, and I got, oops, this should be a 2y, not a 3y. -2y, and I got a -6 there. -6 minus 6 is -12, so the first one checks out. That one's good. So it must be the bottom one. So 2 times -2, and 4 times y in this case is 3. And the book thinks that equals 9. 2 times -2 is -4. 4 times 3 is 12. Well, there it is. -4 plus 12 is not 9. -4 plus 12 is 8. So that one equals 8. 8 and 9 are not the same. So this one's going to be a no. Okay, so you're plugging in the first number since that's your x, second number for y, and it has to be true for both. If it's not true for both, it's going to be a no. All right, second part of the problem on your homework is reading these graphs. Okay, so the problems are going to be graphed for you. It's asking what the answer is. So it's asking find your solution. Use the graph to find the solution. And it wants us to check it. We don't have to do that because the graph is already done for us. So it wants us to find the solution. And the solution is just where they're intersecting there. So all I have to do is look at these graphs and see where are these graphs intersecting. So this first one is intersecting at 2, -2. That's my answer, where they're intersecting. Second one, number 8, is intersecting at -1, -3. And then my last one's intersecting at 4, 2. Okay, so remember, this is the x, this is the y. We're just finding where they intersect on the graph. Okay, so these are already done for us. So those are the first two kinds of problems. The last one, always the most difficult. Now we have to graph them, and now we have to see where they're intersecting. And I'm going to do these in 2 different colors so we can kind of tell. Okay, so remember, when we graph, we always start at this number back here. So since this number says +3, I'm going to put a dot at up 3 on the y-intercept. Okay, so always starting at whatever that y-intercept is. My slope, remember, is always in front of the x. In this case, it's a negative x, so that means -1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Very important for these problems to make sure that your line goes all the way through your graph. Okay, otherwise it might be hard to see on the second equation where everything else is going. So here, this one says x plus 5, so that means I'm going to start at up 5. My slope is a +1, so that means I'm going to go up 1, right 1, and then I kind of run out of room there. So this is very important again, that we are able to draw straight lines here. So it's going to be tough for Mr. Molo because Mr. Molo is not very good at straight lines. And now we can kind of see where they're intersecting. They're intersecting right there. And that point of intersection is -1, 4. So that's where our graph is. It's going to be a lot easier for you guys because you're on big ideas and the graph is going to be a straight line for you anyway. You just need to put the 2 points in there. But if you're ever doing this on paper, you might want a ruler or something because this is going to be a little tougher to draw straight lines. Okay, let's look at another one here. So I'll do this one in blue and this one in purple so we can see the difference. So I got a +2 here. So I'm starting up 2. And here my slope is 1/2. So that means rise 1 and run 2. Okay, so I'm going to rise 1 and run 2. Draw as straight of a line as I can. Okay, and now here I got a +4, so I'm going to start up there. And now my slope is -1 over 2. So that means I'm going to go down 1 and right 2, and down 1 and right 2. Draw again as straight as line as I can. And I see that they're crossing right there. And that point is at 2, 3. All right, 12 and 15 I'm actually not going to do. They don't say y equals, so they're very not nice for graphing. Remember, if you do have, I think I gave you one of these on the homework. Remember, you have to get them to say y equals first. So that bottom one already says y equals. So let's just get this top one to say y equals quick. So 3x minus 2y equals 6. So remember, we got to get the x's on one side. And we got to get the y's on the other side. So subtract, I had to subtract your x's. In this case, since it's a +3x, I'm going to subtract 3x. And then divide by whatever's in front of the y. So here's it in y equals form. Oops, it's a -3. Okay. So again, I think I gave you one of those on the homework. Otherwise, it's pretty much the same thing. Let's look at another one of these that has a fraction in there. Okay. So like number 14. I'll do this in green, this one in red. So 1/4 x plus 3. So start up 3, and then up 1 over 4. Draw again as straight as line as I can. This one, I got 3/4 x plus 5. And this is why I wanted to do this problem. I can't go up 3 and right 4. So instead of going up and right, I'm going to end up going down and left. And that's the same thing, because that's negative over negative. So that ends up giving me the same answer. So remember, if there's ever a graph that you can't go up and right, remember down and left are the same thing. So up is positive, down is negative, right is positive, left is negative. So something like 2 over 3 is the same as -2 over -3, because the two negatives will end up canceling out. And then last thing I did want to talk about before this one is on this line here, y equals -3. Remember, if it's y equals a line, that means you're doing a straight horizontal line across. If it was x equaling a line, it'd be a straight vertical line. So make sure that you're looking at that stuff too. So if I just finish this problem here, y equals 3 over 2x, we could see up 3 over 2 that this graph is crossing right there at that y-intercept of 0, -3.